All right, folks, we're ready to get started. Sorry about the delay. Life happens sometimes. Welcome, everybody. It's nice to see a lot of you that I don't normally see. Uh, but it's even nicer to see the majority of you that I do normally see. Welcome to the last week of class. Just two more meetings, and then we're done. The finals next week at some point. I don't know exactly when. I think it's Tuesday at 8 in the morning. It is what it is, but that obviously will be the last time we meet. I'll have the papers graded by the time that happens, and I'll upload the grade as well as the mini paper grades, and you'll have all that so that you know your standing going into the final. But as I mentioned before, there's no way to calculate what you need on the final to get a particular grade because the class is curved, and so the brackets for the grades will reveal themselves once all the points have been tabulated. So all you can do at this point is just do your absolute best to prepare for the final and do as well as possible on the final. Are there any questions about anything you'd like me to address yet? Okay. Yeah, just two for the final, yeah. If it's a little bit under, it won't be too bad. But if it's like you miss the mark and it's clear, then that will hurt your grade. Yeah. Because that's a university requirement. That's not my requirement. Oh, more is fine. More is fine. More is always better than less. Remember that whenever you're bringing food to a party. All right. Are there any questions about anything you want me to address before I move forward with the final chapter for the course? All right, very good. So the final chapter has to do with the economics of information, essentially dealing with a bunch of sort of issues related to the availability of information, both by consumers and by suppliers, and sort of ways that we go about accounting for the fact that there is imperfect, as we call it, information in markets, and thus things don't work out in the ideal way that we have laid out in the models that we've been studying. But again, that is meant to give you a benchmark case for the most ideal of circumstances in any situation that we've covered, in which everything is known and the approach is clear. But obviously in life, that's not the case. So that's why, again, like here, you learn sort of like the starting point to understanding what you may ultimately be involved in, whether it be you're working for a firm and you're a manager at some level, or you're running your own business. Again, this is about providing you basic intuition about, things that you may encounter, and then obviously you bring in other knowledge from your other courses, you bring in your own sort of creativity and ingenuity, and that married with the information you learn helps you to ideally manage in the best way possible. So that's something to keep in mind. But again, this last chapter will cover some sort of issues related to the sort of imperfection that ultimately you will encounter in reality, where you will not have all the information you need. So one thing that we can do is sort of use statistics to kind of, identify those possibilities that might be better options than others. And so we'll cover the mean and the variance, which will give us, again, a statistical indication of how risky a situation might be versus another situation. These are concepts you've probably covered already in statistics, but we'll cover it again. Then we'll cover uncertainty and consumer behavior, just some issues related to the consumption side of things. And then some issues related to uncertainty and the firm. And then we'll finish off the chapter on Thursday with uncertainty in the market. And then we'll talk about auctions, different types of situations where, again, there might be some bidding going on. And there's different types of auctions beyond the ones you may have already encountered. And so the last section kind of gives you insights into how to best bid in those auctions, and also if you're going to be selling something, what might be the best type of auction to use in those situations. All right, so the mean and the variance. So the easiest way to summarize information about uncertain outcomes is to use the statistical concepts of mean and variance of a random variable. So suppose there's some uncertainty regarding the value of some variable you might be encountering. So let's say the random variable is just generally stated now as a placeholder x, and that could represent profits, the price of output, consumer income, etc. So given certain probabilities about what may happen, different values of the random variable obviously will occur. Suppose someone promises to pay you in dollars whatever number comes up with a fair die toss. So a fair die is one that's evenly balanced and will, again, have an equal likelihood of any side popping up with a roll. If we let X represent the payment to you, again, reflecting the number on the die that pops up, if you are lucky, you're going to roll a 6 and you'll be paid the $6. If you're unlucky, you're going to roll a 1 and you'll get paid $1. The probability that any number between 1 and 6 is rolled, and therefore it will be 1 out of 6. You have 1 out of 6 possible outcomes, and so any particular outcome has a 1/6 probability of occurring. So the expected value, or the mean, of X is then given by the weighted average of all possible outcomes, weighted by their respective probabilities of occurring. So the expected value of this particular situation will be, again, there's a 1/6 probability that you'll roll 1, you'll get $1, plus a 1/6 probability you'll roll 2 and get $2, plus a 1/6 probability you'll roll 3 and get $3, and so on and so forth. And so then, therefore, the expected value, once you get all the numbers worked out, will equal, in this case, $3.50. So again, given the circumstances of this gamble, essentially, of if you roll a die, you'll get the dollar amount on the face of the die that pops up. The average outcome is going to be $3.50. So even though you don't know for certain how much you'll be paid when you roll the die, on average, you will earn $3.50. Generally, if the possible outcomes of a random variable are, let's say, x1, x2, all the way to xn, in this case, the possible outcomes were 1, 2, 3, 4, 5, or 6. And the corresponding probabilities of the outcome are q1, q2, all the way to qn. In this case, they were all the same. They were 1/6 each. The expected value of x will then be given, again, by the weighted average of all possible outcomes weighted by their respective probabilities of occurring. So again, you have some outcome x1, its probability of occurring is q1, so you'll have that first term, plus again, second outcome q2, weighted by its probability of occurring q2, all the way to qn, where the sum of all probabilities will equal 1. Again, if you look at a set of possible outcomes, something is going to happen. And even if that something is nothing, that will also have a probability of occurring. So ultimately, all probabilities of a set of outcomes will sum to 1. The mean of a random variable, again, what we just calculated, collapses information about the likelihood of different outcomes into a single statistic. So it's not the best statistic, as I'll highlight in a second, but it is useful to, again, collapse the information you have into a single number that, again, can be an indicator of what may happen in a situation. But it provides no information about the degree of risk associated with the random variable, and that's the shortcoming of the mean. So to illustrate the importance of considering risk in making decisions, consider the following two options. You have one option, you flip a coin. If it comes up heads, you receive $1. If it comes up tails, you pay $1. Option 2, you flip a coin. If it comes up heads, you get $10. And if you get tails, you lose $10. So even though the stakes are much higher under option 2 than option 1, each option has the exact same expected value, in this case of 0. So the expected value of option 1 is, of course, 1/2 the probability of getting heads and getting $1, plus 1/2 the probability of, getting tails and then losing $1. So the expected value of option 1 is 0. And the same thing is the case for the second option. Again, 1/2 probability of getting $10 plus 1/2 probability of losing $10. So again, you've got Gesundheit, that was a sneeze. You've got a you got two sets of options, and they're very similar, and the expected value is going to be identical, but the degree of loss obviously is much greater with the second one than with the first one, and the mean does not indicate that. So again, this collapsing of information is such that you lose some information about the riskiness of an option by just looking at the mean. So by summarizing information about the options and using the mean, we've lost some information about the risk associated with the two options. So given the deviations from the mean are much larger under option 2 than under option 1, again, like you could lose 10 or gain 10 versus lose $1 or gain $1, option 2 can be thought of as being riskier. So it's more convenient for a manager to have a number that more succinctly summarizes the risk associated with random outcomes. And of course, that number is the variance of a random variable. The variance of a random variable is the sum of the probabilities that different outcomes will occur times the deviations from the mean of the random variable. We talked about the variance in the statistical chapter, chapter 3, in which we did the regression stuff, but we didn't actually calculate it. So we'll calculate it here. I'm assuming you did calculate at some point in your past. So formally, if the possible outcomes of a random variable, again, are x1, x2, all the way to xn, these are the possible outcomes, like in the die example, it is the values that would pop up on the die. Their corresponding probabilities are q1, q2, all the way to qn. So that means that the expected value of x is going to be given by, and the expected value of x is given by e to the x. So you need to calculate the expected value as well to get the variance. Then the variance of x will be given by, and the variance of x is denoted by sigma squared. If you remember, the square root of the variance is the standard deviation. So that's represented by sigma. So again, it's going to be the weighted average of all the deviations of each possible outcome from the mean squared. So we square them in order to get rid of like negatives, in order to sort of get rid of that that element, which could obscure the meaning of the final statistic. So you have, again, some expected value, you have some outcome that could happen, and you have the difference between those, so how far that outcome is from the average outcome. You square that, and then you multiply it by its respective probability. So that's for the first option. Second option, same thing, x2, subtract the expected value, square that, and then multiply by its respective probability of occurring, all the way to the nth outcome. Again, x to the n minus the expected value squared times the probability of that outcome occurring. So again, the standard deviation is simply the square root of the variance, and again, it's just the square root of this entire expression here. So the standard deviation has very practical applications. The outcomes for any random variable always will fall within 2 standard deviations of its mean at least 75% of the time. So again, it's sort of a way of kind of gauging like how sort of spread out the possible outcomes can be. So it's telling you basically how much instability there is in this process that you're studying. So back to the coin tossing example. In each case, only 2 possible outcomes occur with equal probabilities. The variance of option 1, therefore, will be, you've got, again, like if you get heads, you get $1. We calculated the expected value was 0, so then the deviation from that is 1. Square that and then multiply it by its respective probability of occurring, which is 1/2. Plus, and then again, you get tails, you lose $1. Subtract that from 0, square that, and then multiply by 1/2 the probability of that happening, and that's going to get us to 1/2 plus 1/2 equals 1. So the variance of option 1 is equal to 1. Whereas the variance of option 2 is equal to 50. So again, like we know going into this that the second option holds a lot more risk because you can lose a lot more. And so the variance is going to be a lot larger, and it's going to reflect that. It's going to reflect that the degree of riskiness of that second option is higher than that of the first. So make sure that you, I'm sorry, it was 50 plus 50, which equals 100, so it's even larger than I stated. Since again, option 1 is equal to 1, and that's less than the variance of option 2, then option 2 is more risky than option 1. Make sure that you are able to calculate variance and mean. Since the standard deviation is the square root of the variance, the standard deviation of option 1 is 1, and the standard deviation of option 2 is equal to 10. Quick demonstration problem. The manager of XYZ company is introducing a new product that will yield $1,000 in profits if the economy does not go into a recession. However, if a recession occurs, demand for the normal good will fall. So recessions occur, incomes shrink, normal goods. If incomes go down, people buy less of those things. So for this thing, whatever it is, the demand for it will fall sharply, and the company will wind up losing $4,000. If economists project that there's a 10% chance that the economy will go into a recession, the question is, what are the expected profits to XYZ company of introducing the new product? All right, so remember, the probability of all possible outcomes have to sum to 1. So if there's only 2 possible outcomes, there is a recession or there is not a recession, and you're given a 10% probability there will be a recession, that means there's a 90% probability that there will not be a recession. We're also being asked how risky is the introduction of the new product, so therefore we will have to calculate the standard deviation for the situation. All right, so if there's a 10% chance of a recession, there's a 90% chance there will not be a recession. Using the formula for the expected value of a random variable, the expected profits of introducing the new product are found to be, again, there's a 10% chance that there is a recession and that introducing the new product will result in a $4,000 loss, plus a 90% chance that there will not be a recession and the firm will earn $1,000 in profits. And therefore, the expected value to this business venture is going to then equal, in this case, $500 if you do the math. All right, so using variance as a measure of risk, we then calculate the variance. Again, we're going to look at the distance from each outcome from the mean, square that, and then weight it by its respective probability of occurring. Yes? Yeah. All the numbers are specific to that particular product. So yeah, it just reflects the likely outcome for the circumstances that the manager faces. Yeah. All right, so the variance. So again, you've got negative 4,000 is the outcome. Subtract that from the mean, square it, and then multiply it by its respective probability of occurring, which is 10% chance that, again, the economy will tank. Plus, again, 0.9 probability, and then you're weighting that, again, the deviation of the outcome, which is 1,000, from the mean, which is 500, and you're squaring that and multiplying again by its respective probability of occurring. So if you do the math right, and again, order of operations, you got to do parentheses, exponents, and then multiplication, and then addition. In this case, we see that the variance is very large. In this case, it's over 2 million. So that just reflects the fact that it's a risky endeavor. All right, so that's the mean and the variance. Now let's talk about some issues related to uncertainty and consumer behavior. So we'll turn to the presence of uncertainty and how it affects economic decisions on both consumers and managers. So one thing that we have to take into account whenever we are dealing with uncertainty in any kind of analysis is, what is the attitude towards risk of the agents within the models that we're using to kind of analyze situations. Are they like really willing to take on a lot of risk? Are they afraid of risk? Or are they just like indifferent to risk and it's all about the return? So if they are afraid of risk, we say that they are risk averse. So in chapter 4, we assume consumers have preferences for bundles of goods, which were assumed to be known with certainty. Here we extend the analysis to preferences over uncertain outcomes. If we let F and G represent two uncertain prospects, let's say F represents the prospects associated with buying $100 shares of a stock in some company F, and G represents the prospect associated with buying 100 shares of stock in some other company G. With stock, you are uncertain what your actual profits or losses will be. Ultimately, of course, companies do project what their profits will be into the future, and that gives you an indication of whether or not a stock is worth buying. But of course, the economy is an uncertain animal, and people do crazy things sometimes that leads to outcomes that we cannot foresee, and so that will affect interest rates, which affects the present value of profits. It also will affect the actual profits of the firm, which will affect the price of the stock, because the stock does reflect the discounted present value of future dividends that the firms are expected to earn. So what is known is that there is some mean and variance in the return associated with each stock. So that's all we can really know. Different people exhibit different preferences for the same set of prospects. You may prefer F to G, while a friend may prefer G to F. The differences reflect taste for risky prospects. Again, a risk-averse person prefers an amount, some sure amount, which we'll just call M right now, to a risky prospect with some expected value of M. So this is uncertain, whereas this is certain. A risk-averse person will always take the certain outcome versus the risky one. A risk-loving person prefers a risky prospect with an expected value of M to the sure amount of M. And of course, a risk-neutral person is indifferent between a risky prospect with an expected value of M and a sure amount of M. They are indifferent. What ultimately will matter to them is that there is a positive expected value. If there is, then they'll likely take it if they're risk-neutral. It is possible for individuals to vary in their attitude towards risk depending on the magnitude of the risk. And so we need to account for that whenever we are sort of trying to assess the kind of decisions that maybe a lot of individuals in a particular market will make with respect to stocks that they're interested in buying, or like the willingness to invest in particular projects. Like in order for us to try to sort of forecast the best we can what may happen in markets, we have to take into account how we think that the population in those markets will behave. So if we're talking about like hedge funds tend to be generally risk neutral, maybe even risk loving, versus like individual investors that are like a little bit older. They tend to be more risk averse. So and again, each of these players in markets will choose different assets to invest in. So if you're projecting prices of assets and you are accounting for consumer behavior in those markets, then you have to specify the attitude towards risk of the representative agents in those markets, which we specify via a specific form of a utility function. This is all stuff beyond the scope of this class, but you have to understand that all of this is very relevant to sort of trying to whittle down uncertainty as much as possible in a very uncertain world that we all live in. So let's talk about managerial decisions that reflect the markets in which they deal with risk-averse consumers, which is a lot of product markets. Most consumers tend to be risk-averse. We don't just like buy things that we know to likely wind up being a lemon or being something that we ultimately will find useless. So for gambles with non-trivial outcomes, most individuals will be risk-averse. There are important implications of risk-averse consumers for optimal managerial decisions. So one thing we could look at is product quality. Firms use two primary tactics to induce risk-averse consumers to try a new product. The first, prices of new products may be set below those of established products. So if people are afraid to try new products, then obviously a way to lure them in is by giving them really great prices, or maybe even just free samples. Second, the manager can attempt to make the consumer think that the expected quality of the new product is higher than the certain quality of old products. And of course, that's done through advertising. If consumers are convinced by such an advertisement, they may go ahead and purchase the new product because its higher expected quality offsets the risk associated with trying a new product. Another approach that managers can use is to focus on expanding an existing brand of whatever it is that people buy in order to purvey that sense of like dependency, that you can depend on names that you know versus names that you don't. So chain stores is an example. So risk aversion also explains why it may be in a firm's interest to become part of a chain store instead of remaining independent. A consumer that drives through some small town USA and decides to eat lunch will typically prefer to make purchases at chain stores. You never know when you'll walk into the local diner and just have a really horrible experience with the locals and the people that work there. But if you go to a chain store that is beholden to a brand that is international or even national, and they will be accountable beyond like the small interaction in this like remote geographic location, then you're more likely to have a better experience at those places. And so, that will tend to lower the uncertainty and will tend to satisfy the risk-averse customer. So local customers are more inclined to shop local. Even if local stores offer a better product than the national chain can remain in business if the number of out-of-town customers is large enough. So I know there's like this big debate that's been going on for the last couple of decades about like independent versus like chain stores and like how we should buy local and all this stuff. And that does make sense to an extent, but like we also do have to acknowledge that like there is a sense of certainty that we can carry by going into like the Red Lobster in small town USA versus like Joe's Diner. You never know who Joe is. You never know what he's going to think about outsiders. So that's the way it is. Anyway, insurance. Insurance is, of course, a way that we lower uncertainty and make customers more comfortable, given that they are generally risk averse. So risk aversion implies that consumers are willing to pay to avoid risk. Doing so allows individuals to give up a small amount of money to eliminate the risk associated with a catastrophic loss. To a consumer, insurance represents a purchase of a sure thing. Some firms give insurance to customers through money-back guarantees. Other firms sell a form of insurance to customers, such as like extended warranties. We have means of sort of calculating how much people are willing to invest in insurance in order to lower the amount of certainty. It's a whole area. It's called actuarial work. There's a lot of money to be made there. It's kind of boring ultimately, but it's lucrative. So if you're interested, pricing in insurance markets is a big deal, and it can make you money. All right. So another thing we can use to sort of understand the behavior of a risk-averse consumer is what's called a consumer search model. Search models are not just used within the context of how consumers will search out and decide on a certain price for an object. It's also used to study labor markets and in any kind of situation where there's searching involved. And it's a very powerful approach, but we will again kind of lighten the complexity of it here, just to kind of give you a bare bones introduction into what a search model is and how it might work, specifically within the context of consumption. So the analysis of consumer choice is complicated when consumers do not know the prices charged by different firms for the same product. Suppose consumers do not know the prices charged by different stores for, let's say, the same watch. A consumer would like to purchase a product from the store charging the lowest price. So we'll let C denote the cost of obtaining information about the price charged by an individual store. That can be time that they need to spend. It can be an implicit cost, or it can be an explicit cost if they have to pay for some resource to find what they're looking for. Suppose that 3/4 of the stores in the market charge, let's say, $100 for a particular brand of watch, and there's 1/4 of the stores that actually charge $40 for the watch. If the consumer locates a store that sells a watch for, let's say, $40, then obviously she will stop searching. She's gotten the lowest price. A risk-neutral consumer will wonder what to do if she visits a store that charges $100, because a risk-neutral consumer obviously is indifferent to risk, is willing to take on risk, but again, if they are going to lose by taking a gamble, then they'll stay away from it. So again, like if they spend more time searching for another store trying to get that lower watch price, and they wind up getting another high price watch, then that will be a loss to them, and so they wonder whether or not they should continue the search. For simplicity, suppose a consumer searches with free recall and with replacement. That means that, so free recall means that the consumer is free to return to any store that they've already gone to anytime to purchase the watch for the price they found it at. And replacement means that the distribution of prices charged by other firms does not change because the consumer has learned that one store charges $100, meaning that, again, you still have basically the 3/4 of the store that charge $100 and the 1/4 that charges $40, regardless of what the individual outcomes are for the consumer. Under these assumptions, if the consumer searches again 1/4 of the time, she will find a price of $40, and thus she will save $60. 3/4 of the time, the consumer will find the same price of $100. The expected benefit of an additional search is thus equal to, again, we are looking at an expected value here, so we're looking at the average outcome to an additional search. So an additional search will either land them in a better position, and so they will save, again, $60, and that is weighted by the probability of 1/4, because that's, again, the probability of finding a store, 1 out of 4, that does have a lower price, plus the possibility that going on an additional search will yield no benefit, and the consumer will find a watch at the same price, and so they will, again, have zero in terms of benefit, and that will be weighted by the respective probability of occurring, which is 0.75. So doing the math gets us to $15. So the expected benefit of an additional search in this case is $15. The consumer should search for a lower price so long as the expected benefits are greater than the cost of an additional search. If the cost of each search, let's say, is $5, the consumer will find it in her interest to continue the search for a lower price, given that the expected benefit of an additional search is $15. If the cost of searching once more for a lower price is $20, it does not pay to continue searching for a better price. So this example reveals that the expected benefits of searching depend on the lowest price found during previous searches. All right, so if the lowest known price is P, the expected benefit from searching for a price lower slopes upward, since the savings associated with finding even lower prices diminish. So as the price increases, then the expected benefit of finding a lower price is higher, because again, it's likely that you will find a lower price if you're at the highest price possible and you're going to do additional searches. But if you're like at a low price, the likelihood, the expected benefit of getting an even lower price is really low, and that's why we've got this positively sloped expected benefit curve. The cost of each search is, we assume, to be constant at C. So if the consumer finds a higher price than R, so the point at which these two curves connect is R, and that is called the reservation price. So if the consumer finds a price higher than R, the expected benefit of searching are greater than the cost, and the consumer should reject the price, continue searching for a lower price. So again, if the consumer has found a price that is too high, above their reservation price, then for them the expected benefit of an additional search will outweigh the additional cost, and so they will move forward with an additional search. If the consumer locates a price below R, it is best to accept this price, stop searching, and purchase the price. So R is what we've been talking about the entire semester as, again, the willingness to pay, the reservation price of a consumer, and this is just a way of kind of modeling how that price is set inside the consumer, given their sort of calculation of expected benefit and cost. So if the consumer located a price of R, she would be indifferent between purchasing at that price and continuing to search for a lower price. She would essentially just accept it. So R is, again, called the reservation price. It's the price at which the consumer is indifferent between purchasing at the price and searching for a lower price. Formally, if the expected benefit of P is the expected benefit of searching for a lower price than P, and C represents the cost per search, the reservation price satisfies the condition that the expected benefit of the reservation price equal the cost. So again, that is the point that sort of defines the reservation price. Beyond that point, searching more has a greater likelihood of finding a lower price than the cost it would incur, versus a lower price. If let's say the consumer found a low price, then to search further, they would have to pay costs of this much, and their expected benefit is this much. So obviously, it wouldn't be worth it to them to continue searching. So that gets us to the principle of the consumer search rule. The optimal search strategy is to search for a better price when the price charged by a firm is above the reservation price, and stop searching when a price below the reservation price is found. So what happens if the cost of searching increases? Well, we see what happens graphically here. The cost of searching goes up. That means that the reservation price will obviously increase, right? So now there is only this range over which, if they find a high price, it is worth it for them to continue searching, versus if they are along this range now, then the expected benefit of an additional search is going to be less than the additional cost of the search, and thus they would not do it. So this means that the consumer will now find more prices acceptable and will search less intensively. As things have played out in our society, though, the cost of searching has dramatically decreased, given that a lot of purchasing has gone digital, and thus it doesn't really take that long for us to kind of comparison shop and look for alternatives, and thus reservation prices have actually gone a lot lower. So that means people are willing to search a lot more now, given that they have more information available to them at essentially zero cost. But again, there is the opportunity cost of time that is always a constant factor in there. Similarly, if the cost of searching for lower prices falls, the consumer will search more heavily for lower prices, which is what we've seen. So this analysis of a consumer's decision to shop for lower prices can be used to aid managers in setting prices. When consumers have imperfect information about prices and search costs are low, the optimal prices set by a manager will be lower than when search costs are high. Managers must be careful not to price their products above consumers' reservation prices. All right, so just make sure you understand this framework and what it implies about how a consumer goes about searching and what happens when costs change. All right, now let's move on to uncertainty and the firm. So in this section, we'll examine the implications of uncertainty for production and output decisions. So let's look at the risk-averse manager. A manager who is risk-neutral is interested in maximizing expected profits. The variance of profits does not affect a risk-neutral manager's decision. Again, the variance tells us how risky a particular investment option might be, but for a risk-neutral person, they are only interested in the outcome, whether it be positive or not. If it is positive, then they'll likely go for it regardless of how risky it is. If the manager is risk-averse, he or she may prefer a risky project with a lower expected value if it has lower risk than one with a higher expected value. So for a risk-averse manager, the variance will play a role. In general, for the manager willing to undertake a risky project, the project must offer a higher expected return than a comparable safe project. Just how much higher depends on the manager's particular risk preferences. Managers should carefully evaluate the risks and expected returns of projects and document the evaluation. A manager is less likely to get fired over a bad outcome if she has provided evidence that the decision was sound based on available information at the time. A convenient way to do this is to use the mean variance analysis. Quick demonstration problem, just to kind of highlight how that would work. So let's say you have a risk-averse manager and they're considering two projects. The first project involves expanding the market for bologna. The second involves expanding the market for caviar. There's a 10% chance of a recession and 90% chance of an economic boom. During a boom, the bologna project will lose $10,000, right? Because it is what kind of good? Inferior good, exactly. It is an inferior good. If there's an economic boom, people's incomes go up. They buy less of the inferior goods, right? People will buy less bologna. So that project will lose $10,000, whereas the caviar project, which is extreme, most people don't buy caviar, but whatever, let's just go with it, will earn $20,000 during the economic boom. During a recession, the bologna project will earn $12,000 and the caviar project will lose $8,000. If the alternative is earning $3,000 on a safe asset, like let's say a treasury bill, which is a bond issued by our treasury department, a bill is a short-term bond which lasts less than a year. What should the manager do and why? All right. So the first thing the manager should do is to summarize the available information to document the relevant alternatives, which we can do here. And again, they can look at the mean, given that there's a 10% chance of a recession and a 90% chance of a boom, and the standard deviation of each possible outcome. The first thing to note is that the manager should not invest in a treasury bill. So investing in a treasury bill has basically no uncertainty associated with it. Regardless of what happens, they're going to earn $3,000. But the joint project, working on both caviar and bologna, will generate profits of $4,000 in a recession. So that's the worst possible outcome. But from the joint project, which is greater than the $3,000 certain outcome for the T-bill option. So regardless of what happens to the economy, the manager is assured of making at least $4,000 under the joint project, which is greater than the return of $3,000 on the treasury bill. The second thing to note is that the expected mean or expected profits of the bologna project are negative. So we see that here. So regardless of the fact that the $12,000 is a fairly sizable amount of profits, the likelihood of a recession is low, and therefore this loss of $10,000 when there's a boom is weighted highly, which leads to an expected value that is negative. So a risk-averse manager would never choose that project. Neither would a risk-neutral manager. Again, a risk-neutral manager wouldn't take a gamble if it has a negative expected value. The manager should adopt either the caviar project or the joint project, given those circumstances. Precisely which choice the manager will take depends on his or her preferences for risk. So the returns associated with the joint project in the preceding problem reveal the important notion of diversification as something that I'm sure you guys are all aware of. It's sort of the mandate of a hedge fund, right? Like they invest in a variety of different investments that vary in the degree of risk, which spreads out the risk, which is what we call, again, diversification. By investing in multiple projects, the manager may be able to reduce risk. Whether it's optimal to diversify depends on a manager's risk preference and the incentives provided to the manager to avoid risk. While many managers are risk averse, generally the owners of the firm, the stockholders, want the manager to be risk neutral. So they themselves, the stockholders, have their own sort of diversified approach to how they invest, and so they don't necessarily want managers to behave in that same way, because managers have less of that ability to kind of diversify their risk. So a manager who is risk neutral cares only about the expected value of a risky project, not the underlying risk. A risk neutral manager's objective is to take actions that maximize the expected present value of the firm, actions that maximize expected profits. A risk neutral manager would choose a risky action over a sure thing, provided the expected profits of the risky project exceed those of the sure thing. So again, like the risk-averse manager will go for these two options, which is not what the risk-averse manager would do, and so the stockholders would want the manager to take the bigger risk and go for the caviar project, because again, it would yield the highest amount of profits. So shareholders want managers to take actions that maximize expected profits, even when doing so might involve considerable risk because of their own ability to diversify. Shareholders pool and diversify risk by purchasing shares of many different firms. It therefore is inefficient for managers to spend time and money attempting to diversify against risk. When doing so will reduce the firm's expected profits. So essentially, what is being suggested here is that it is good to be risk neutral when managing, and to be willing to take risks, but obviously to be able to gauge how much risk there is and not just be risk loving and just kind of blind to how much risk there is. Like, you want to be risk neutral. You don't want to take the baloney project that's going to have an expected value that's negative. All right. Now, another way we can sort of account for uncertainty is in the process that managers go through in searching out employees. So that's another way we can apply the search model on the producer side. So just as consumers search for stores charging low prices, producers search for low prices of inputs. When there's uncertainty regarding the prices of inputs, optimizing firms employ optimal search strategies. The search strategy for a risk-neutral manager will be precisely the same as that of a risk-neutral consumer. So let's do a demonstration problem to kind of just highlight that parallel. A risk-neutral manager is attempting, let's say, to hire a worker. So they're looking for the ideal candidate for, some position. All workers in the market are of identical quality, but differ with respect to the wage at which they are willing to work. So in this case, workers have a reservation wage. Suppose half of the workers in the labor market are willing to work for a salary of $40,000 and half will accept a salary of $38,000. The manager will spend 3 hours interviewing a given worker and values his own time, the manager's time, at $300. The first worker the manager interviews says he will work if he's paid $40,000. So the question is, should the firm manager make him an offer or interview another worker? All right, so again, this is an optimal search problem that has search costs of $300. If the manager searches for another worker, half the time she will find another worker willing to work for $38,000 and thus will save $2,000. But half of the time the manager will find a worker just like the one she chose not to hire, and the effort will have been for nothing. Thus, the expected benefit of interviewing another worker is, again, so we can do the expected value approach to figure out what the expected benefit of searching for an additional employee might be. So again, manager could search again, interview another person, and save those $2,000. And again, there's a 1/2 probability of that happening versus 1/2 probability of searching again and not saving any money. So the expected benefit is $1,000. Since this is greater than the cost of $300, the manager should not hire the worker, but instead search for a worker willing to work for $38,000. All right, I think this is the last section for today. So the last thing we'll consider today is uncertainty with respect to profit maximization. So again, we've been working on profit maximization the majority of the last 2/3 of the semester. We figured out the conditions that managers need to use to set their optimal output to maximize their profits. But again, that was considering that the manager had all the information they needed. So the basic principles of profit maximization can also be modified to deal with uncertainty. Suppose the manager is risk neutral and demand is uncertain. The risk neutral manager must determine what output to produce before she is certain of the demand for the product. Since demand is uncertain, revenues will be uncertain as well. To maximize expected profits, the manager should equate, therefore, expected marginal revenue with marginal cost in setting output. So again, they don't know exactly what the revenue will be, and so they'll have to do a weighted average of the possible revenue outcomes, set that equal to their marginal cost, and then that will allow them to kind of ballpark how much they should be producing in an uncertain world. Let's look at how that works via this demonstration problem. So Appleway Industries produces apple juice and sells it in a competitive market. So if they sell it in a competitive market, what is their optimal output rule? It's a perfectly competitive market. So they set output via what rule? Marginal cost equals what? Price. Marginal cost equals price. Remember, for Only competitive markets, price equals marginal revenue. So they said price equal to marginal cost versus any other industry in which there's market power. They said marginal cost equal to marginal revenue, which is less than price, right? And then they get to do the markup, depending on, again, how competitive the market is. All right, so they sell in a competitive market. The firm's manager must determine how much juice to produce before he knows what the competitive price will be. Economists estimate that there's a 30% chance the market price will be $2 per gallon and 70% chance that the market price will be $1 per gallon when the juice hits the market. So if the firm's cost function is given by this expression here, how much juice should be produced to maximize expected profits? All right, so, and then we're going to look at what the expected profits of the Appleway industry are. All right, so the profits of Appleway Industries are given by, of course, our standard profit equation, price times quantity minus the cost of producing the quantity. Since price is uncertain, the firm's revenues and profits will also be uncertain. For a competitive firm, again, marginal revenue equals price, thus marginal revenue also is uncertain. Marginal cost is given by, of course, our derivative to our cost function. So 2 times 0.005, 0005 times q raised to the power 2 minus 1. So you got 0.001 q is our marginal cost. To maximize expected profits, the manager equates expected price with marginal cost. So the expected price is set equal to marginal cost, and our expected price is given by, again, the weighted average of each possible price outcome weighted by their respective probabilities of occurring. So you've got, again, a possibility the price will be $2 weighted by its probability of occurring, which is 30%, so 0.3, plus the possibility that the juice will be $1 weighted by its respective probability of occurring, which is 70%, 0.7. So the expected price, if you do the math, is equal to $1.30. So equating this with marginal cost, we then obtain, again, 1.3 equals 0.001 Q, and the optimal amount of juice to supply in this uncertain world, in this case, is 1,300. And now we can figure out the profits by just plugging that information in to our expected profit equation, which just includes the expected price in it. That's why we get the expected profit, minus the cost. Expected price is 130. The amount the firm would sell at that price is 1,300 minus the cost of selling 1,300, which again is this expression with Q equal to 1,300 subtracted from the expected revenues, and therefore the expected profits are $645. Any questions on this? All right, so Appleway Industries can expect to make $645 in profits. All right, folks, only one more lecture to go. Good job. So again, if you haven't turned your paper in, leave it there. And that's it. Have a good couple of days. I'll see you on Thursday.